Hi there, I'm Peter, Managing Director of GlasCurtain. We're a Canadian manufacturer of fiberglass framed curtain wall systems. Most of you already know that GlasCurtain is deeply committed to innovation and sustainability, continually developing new curtain wall systems to enhance building envelope performance and optimize facade design, particularly for net zero, zero carbon, and passive house buildings. And since our commercial launch at Greenbuild in 2013 in Philadelphia, you've come to know us as manufacturers of exclusively triple-glazed curtain wall systems. But today, new opportunities are emerging as we expand our Thermaframe family of curtain walls to include our first ever double-glazed solution. To better understand this exciting expansion of possibilities, let's explore some of the high-level differences between double and triple-glazed systems, the factors you'll want to consider when specifying one or the other, and of course introduce you to our latest fiberglass framed curtain wall. Let's start with a few high-level differences between double versus triple glazed IGUs, or insulating glass units. As even the most casual observer can probably intuit, double glazing consists of 2 lights of glass and triple glazing has 3 lights, separated by 1 or 2 spacers respectively. In between the lights are created insulating gaps, typically filled with air or argon to reduce thermal conductivity across the sealed unit. Argon, being a noble and inert gas, is better at insulating than just plain air, and is therefore commonly specified in colder climates. To further improve the thermal performance of the building envelope, low-E coatings are also regularly applied to both double and triple glazed IGU in order to reflect infrared heat, keeping interiors warmer in winter and cooler in summer. Now, in double glazed IGUs, soft, or also called sputtered, low-E coatings, which are usually made from silver, are commonly applied to surface number 2, which is the interior surface of the exterior light, which is, if this is the exterior here, this would be the interior surface right there. That's surface number 2. In triple glazed units, the soft low-E coatings are commonly applied to surfaces number 2 and number 4 in colder climates. The locations are optimized for minimizing thermal stress on the units while also reducing condensation risk and of course improving thermal performance. And speaking of improving thermal performance, in both double and triple glazed IGUs, we're also increasingly seeing hard low-E coatings, or also called pyrolytic low-E coatings, made from more durable tin oxide or titanium oxide. And this is applied to the innermost surface of the inner light, which, if this would, again, on the outside, on the right side would be the innermost light. It would be applied to that surface number there. That's surface number 6. And this additional hard coating even further improves the thermal performance of the overall unit, certainly as far as center of glass U values go. But the performance of an IGU isn't just measured by its center of glass U value. There are also the edge effects to consider, which is to say the thermal bridging around the perimeter of the unit, which is the part of the IGU that actually connects to the curtain wall frame. So for high performance IGUs, we have a variety of solutions at our disposal, starting with warm edge spacers or spacer bars made from materials that are relatively rigid and have low thermal conductivity, such as thermoplastic elastomers and polypropylene, which reduce thermal bridging at the edges of the unit to improve the overall efficiency of the units, and of course, again, also reduce condensation risk, making these solutions ideal for high humidity environments like healthcare buildings or recreation centers. And now supporting these warm edge spacers and spacer bars are what are called primary and secondary seals. So primary seals attach on either side of the spacer bar between the glass lights, and the most common material used for these is butyl rubber, also called polyisobutylene, which is preferred due to its excellent gas and moisture impermeability. Secondary seals form the outer edge of the IGUs and are typically made of silicone in high performance units, which is a material that provides exceptional durability, flexibility, resistant to extreme stresses, and therefore provides long-term durability over a wide range of temperatures. However, even with all of these thermal improvement technologies, whether it's low-E coatings, noble gases, warm edge spacers, or high-performance primary and secondary seals, as they say in the automotive world, there's no replacement for displacement, which is why even the best double-glazed IGUs with all of these other improving technologies can't match the overall thermal performance benefits of triple-glazed units, especially for cold climates. But Peter, you say, you keep talking about cold climates. What if all buildings aren't in cold climates? And you know what? It's a great point, which is why When choosing between double and triple glazing, the number one consideration really is climate zones, first and foremost. After which, we need to consider our overall window-to-wall ratio of our facades, our energy performance targets, and of course, our client sustainability goals and targets. After all, the choice of glazing is critical for successful facade design, but especially so for sustainable and high-performance buildings, which is of course our area of expertise at GlasCurtain. In sustainable and high-performance buildings, it's often not just about adding or taking away a pane of glass here or there, so much as it's about optimizing energy demands, balancing mechanical system loads, maximizing occupant well-being, ensuring long-term facade durability, and of course, achieving our overall vision for the project. And a huge part of the vision of an increasing number of owner-occupied buildings in particular really is sustainability. Thankfully, over the last couple of decades, this part of the industry in particular, which typically leads rather than follows, has gotten much better at improving the operational impacts of building performance. But there's an increasing emphasis on embodied carbon impacts as well, which is the environmental impact from manufacturing, transportation, and installation of building materials. In this context, double glazing is getting a renewed lease on life, if it ever really left. In colder climates where GlasCurtain has completed most of its projects to date, in places like Iqaluit and Yellowknife and Whitehorse, but even in Edmonton and Ottawa and Thunder Bay, triple glazing makes a ton of sense for its improved thermal performance and operational environmental benefits that far, far, far outweigh additional embodied environmental impacts. But in more temperate climates, such as Vancouver and the rest of the Pacific Northwest, as well as Toronto and the Great Lakes region and much of the US Northeast, double glazing is the norm and has been for decades. Not just because of the costs and differences between triple glazing, but the environmental impacts as well that simply outweigh the benefits of the additional third light. In terms of embodied carbon in particular, which of course we've done a whole video on previously, based on a recent life cycle assessment from Cardinal Glass, actually, what we can see is that the manufacturing of triple glazed units with tempered glass have almost double the global warming potential of double glazed units, with 93.9 versus 54.3 kilograms of carbon equivalent per meter squared of IGU. It's about 10.7 feet squared. And that's just for 3mm glass, which is the thickness really only seen in residential punch window applications. The standard for commercial curtain walls is 6mm glass. So we actually double, basically, all of those numbers again for curtain wall systems. And that's a lot of double doubles, eh? The net result in terms of embodied carbon is that a standard curtain wall opening of 1.5 meters by 3.5 meters, which is a conventional triple glazed aluminum framed curtain wall, emits about 1,300 kilograms of carbon to manufacture, whereas our new double glazed fiberglass frame curtain wall only requires about 700 kilograms of carbon. So basically half as much embodied carbon in our new fiberglass frame system. And you still get essentially the same thermal performance as triple glazed aluminum, which is R4. The net result on an average project size of about 10,000 square feet of installed curtain wall is a savings of over 100,000 kilograms of carbon, which is the annual equivalent to 25 cars being taken off the road, or the annual carbon sequestration of over 5,000 trees. Of course, this new fiberglass frame system still won't be the ideal solution for colder climates, but for more temperate climates that are more cooling dominated, our new double-glazed fiberglass frame solution is a fantastic fit, especially for high-performance, sustainable, low-carbon buildings. Of course, even high-performance and sustainable buildings have what you might call budgets, which is why our newest double-glazed system will be a useful 10% less expensive in capital terms than our standard Thermaframe 7 triple-glazed system, making it that much more compelling for projects in more temperate climates, where the absolute best thermal performance in the world is less critical. But even still, our new double-glazed system will have the best thermal performance of any double-glazed system on the market. And this will give architects and owners the opportunity to optimize long-term operational savings with upfront investments, as determined by the cost-benefit analysis of that particular project. What this ultimately means is that the choice between double and triple glazing is, as you probably guessed, far from automatic. Rather, it requires a holistic approach that considers the building's design, its functions, its goals, and of course, its context. By understanding all of these together, we can make more informed decisions to enhance the performance and sustainability of our buildings for generations to come. So with that, we're absolutely thrilled to announce our latest innovation and our latest addition to the Thermaframe family, Thermaframe 4, our first ever double-glazed fiberglass framed curtain wall system. As ever, Thermaframe 4 upholds the same high standards of performance, durability, and sustainability that have defined our company since we launched in 2013, all while offering nearly half of the embodied carbon of aluminum frame systems with similar thermal performance. Overall, this makes our Thermaframe 4 system the ideal choice for temperate climate projects, especially those aiming for sustainable certifications such as zero carbon, net zero, and of course, even the upcoming LEED V5. If you have any questions at all about our Thermaframe systems and which one is right for your next project, feel free to reach out to us by email at info@glasscurtain.ca or visit our website, glasscurtain.ca, click Let's Chat and use the contact form there. Also, be sure to follow us on LinkedIn, Instagram, Twitter, and Facebook for all our latest curtain wall conversations, podcast episodes, as well as latest project news. And you can subscribe to our email newsletter for updates, which we'll link to in the description below. Thanks very much. We'll see you next time.